Hello there, Mr. Sutton bringing you another matrix lesson, this one on Gaussian elimination. So what is that? We're going to use it to solve systems in matrices. For our warm-up, we're going to solve this system using elimination, but we're going to do a special kind of elimination. So a few ground rules. We can add equations and multiply or divide an equation by a constant, which is what you do with elimination, but we're not allowed to use any substitution. Also, we need to write out all the invisible zeros and ones. And one little extra rule, whenever you add these rows together, add these equations together, you have to replace one of these two equations. You might be wondering, why are we putting all these rules on this? There's a few reasons. The big one, though, is that we're pretty much going to do with the process I'm about to show you here, but with matrices. If we do it with equations first, I think it'll make a little bit more sense what we're doing later on. So pause the video and see if you can follow these rules and get an answer out of this. All right, here's what I came up with. So I'm going to label these as row 1 and row 2, R1 and R2, and I'm going to note what I'm doing with the two rows above each step. And I encourage you to do the same so that people can follow your work. Now, the process for solving by elimination, you basically are trying to get rid of one of the variables in one of the equations so that you could then turn around and solve for the remaining variable. And we do this by getting the two equations to have opposite coefficients. So that when we add the equations together, we can actually cancel out one of the variables. But in this case, we don't have any opposite coefficients. We have a -2 up here. We do not have a +2 down here to cancel it out with. Same thing here. We have a +6, but not a -6. So we have to pick a variable and then multiply one of the equations by something that'll help us get rid of that variable. The easiest target here looks to be if we multiply this second row by 2, we'll be able to add these equations together to cancel out the x's in one of these equations. So I'm going to multiply this by 2. That'll give me 2x plus 4y equals -19. And at this point, I'm going to add the two equations together. Now, instead of doing what we do with normal elimination and just getting one equation out of this and then solving for y, I'm going to put my answer from adding these two equations together. I'm going to replace one of these equations with the new equation. I'm actually going to replace this bottom equation with the new equation. The way I'm going to note that up here is I'm going to say row 2 equals row 1 plus row 2. So basically, whatever I get when I add rows 1 and 2, I'm going to replace row 2 with that. Now again, why would you go to all this trouble? Because again, we're going to do the same thing with matrices later on, so we better get used to it with equations. So if I add these together, I'll have 0x down here, 10y, and -22 plus -18 gives me -40. At this point, we need to restrain ourselves and not take the bait and divide everything by 10. I mean, we could, and we would know what the value of y is, but the only way to actually solve this equation following these rules is to get the variable that you don't want to be 0. We've done that with x. We have not done that with y up in the equation up here. So we want to get rid of this y up here so that we have something x and 0y. So let's just go ahead and take care of that before we try to divide and solve for exact variables. So what could I multiply these two equations by so that these y's will cancel? Well, you could multiply them by 10 and -6, but there's a smaller number these both go into, 30. If I multiply the top by 5 and row 2 by -3, I can get those to cancel. So that'll give me -10x plus 30y equals -110, and the second rule will be 0x minus 30y equals 120. I'm going to add these rows together now, and you guessed it, I'm going to put the answer in row number 1, so that each row will have a variable missing. So doing that, I've got -10x up here, this will become 0y, and this over here will become +10. At this point, now that I've got these zeros, I can divide each row by whatever I want, and it's not going to change this 0. That's still going to be 0. So the top row, let's divide that by -10, and the bottom row will divide that by -30, the coefficient of y down here. Doing that gives me x plus 0y equals -1, and 0x plus y equals -4. Or, to put it very simply, x equals -1, y equals -4. So I have my answer, -1, -4. Yeah, that did take a while. It could have been done much faster, like right up at this step. If we were doing normal elimination, we would have just divided by 10 up here, gotten the value of y, plugged it back in, and gotten x. But we're going to do this whole process with matrices, and this will actually help us when we solve systems that have more than just two equations. So there is a method to our madness here. All right, so we've been foreshadowing this for the last couple minutes. We are going to solve a system using a matrix. To do this, we need to turn it into a matrix, and we're going to use something called an augmented matrix. So basically, each equation is going to be a row in a matrix, and there's going to be one element for each item in these equations. So I can make a matrix out of this with just the coefficients 4, 3, 23, 5, -3, and 22. If I do all those row operations that I did on that last page in here, the benefit is now I don't have to keep rewriting these x's and y's. So that saves a little bit of space. It's just numbers we're dealing with now. Now, just like before, I'm allowed to add rows together, just like adding equations, and I'm allowed to multiply or divide a row by a constant, just like we do with an equation, because these really are just equations in disguise. Each row is really just an equation. Our goal in doing this is to get the identity matrix on the left, and then the answer will be on the right. So the identity matrix, just to review from way earlier, that's a matrix where you have ones going diagonally down to the right, and everything else in each row is a 0. So why would I want to just get this? Well, if you recall in the last equation, this really corresponds to 1x, and this is 0y. So if you have 1x here, whatever the constant is over here, that's going to be what x equals. This one down here, these second columns, these corresponds to the y values. This is 1y equals some number. So if we can get this identity matrix, again, whatever's on the right, that's going to be x and y. So let's go ahead and do that now. Taking a look at our original box here, our original matrix, one very easy step to do in the beginning would be to add these two equations together. Now I want to get a 0 up here in the upper right, because that's my identity matrix. So I'm going to make sure that I put my answer from adding these two rows in row 1. So I'll have row 1 equals row 1 plus row 2. So that'll give me a 9, a 0, and a 45. All right, you think you can go the rest of the way? Pause the video and see if you can make it the rest of the way here. All right, so my next target, I want to get a 0 down here. To do that, I need to make 9 and 5 into something that will cancel out. The smallest number that 9 and 5 go into is 45. So if I multiply the top by 5 and the bottom by -9, that'll give me 45 and -45, which will set me up for canceling that out. So top row, that's going to be 45, 0, and whatever 5 times 45 is, I think that's 225. And on the bottom, I've got -45, 27, and whatever -9 times 22 is. Well, 9 times 20 is 180, plus another 18 is 198, so -198. How's that for some mental math? All right, let's add these together. I'm going to put the answer in row 2, because I want 0 down here. So I'm going to have, adding these together, 0, still 27, and now 225 plus 198, that's going to be positive 27. At this point, I know I've only got one more step because, hey, in my animations, here's my identity matrix. But look at this. We've got zeros and then just a single number left in each row. So now we just have to divide each row by whatever that number is that we want to turn into a 1. So first row, we have to divide that by 25. And how about the second row? Well, yeah, 27. So row 1 over 25, row 2 over 27. That's going to give me a 1, which I knew I needed to have. And this 225 is going to turn into a 5. Down here, I'm going to have a 1 and a 1. So that means that x equals 5 and y equals 1. So we're going to step things up a level to show you why this is not a horrible technique for solving systems with a system of 3 equations. These are especially hairy to try to solve without matrices. So let's start by writing our augmented matrix. That'll be a 2, 2, -1, and 2. And then pause the video and write the other spots. So for this next one, we have a 1, -3, 1, and -28. Then we have -1, 1, 0, because there's no z there, and 14. So we do need placeholder zeros. The good news is we've got a 0. The bad news is it's in the wrong place. This is supposed to be a 1. So are these numbers here, 2 and negative 3. And everything else in the left side of our augmented matrix needs to be a 0. So a few tips as you do this with 3 different rows here. One tip is I would get the zeros first. It's much easier to get the zeros first and then divide to get the ones than trying to get the ones and then make everything else 0. Because when you multiply 0 by number, it stays as 0. With ones, that's not the case. Another tip that won't happen on this particular slide but might happen later on at some point in the lesson, you can reduce rows to keep the numbers easy. So even if it doesn't directly give you things that cancel out, sometimes it's just helpful to divide a whole row by a number just so your numbers get a little bit smaller to deal with. All right, another tip that I didn't write down but it's good to keep in mind is it's okay to cancel out or zero out more than one row at a time. We can do multiple row operations in one step as long as we write down what we're doing. So I'm going to start by trying to get zeros here and here in the column 1 and rows 2 and 3 there. So I need numbers that these all go into that can cancel each other out. 2 seems like a pretty easy number. I've already got a positive 2 up here. If I make this a negative 2 and this a negative 2, then I can just add row 1 to rows 2 and 3, and that'll give me zeros there. So to do that, I need to multiply row 2 by negative 2 and row 3 by positive 2. Let's go ahead and do that now. So I'll have negative 2, 6, negative 2, and then 56. Next I'll have negative 2, 2, 0, and 28. Now I'm going to add rows 1 and 2 together and put the answer in row 2. And then I'll add rows 1 and 3 together, and I'll put that answer in row 3. So doing that, this will become 0, 8, negative 1 and negative 2 gives me negative 3, 2 and 56 is 58. Down here, I've got a 0, 2 and 2 is 4, negative 1 and 0 is negative 1, and then 2 and 28 is 30. So I've got some zeros. I'm going to focus on getting zeros up here and down here next. So here's the matrix that I had at the end of the last page. I've just rewritten for our convenience. I need to make a number that will cancel out when I add these 3 rows together now in this column. I've already got a positive 8 in row 2. That's the one that I want to stay the same. I'm eventually going to divide by something to make this a 1, but I want this 2 and this 4 to become zeros. So how about if I make the 2 and the 4 into negative 8s? Let's go ahead and do that. What do I have to multiply row 1 by to do that? Oh, negative 4. How about row 3? Negative 2. So going ahead to do that now, we're going to have negative 8, 4, and negative 8. Down in row 3, I've got 0, so that's not changing. That's nice. Negative 8, 2, and negative 60. Now I'm going to add row 2 to row 1 and put the answer in row 1. Then I'm going to add row 2 to row 3 and put that answer in row 3. So I'll have still negative 8 up here, but now this will be 0, which is what we wanted, and then 1 and 50. Down here, this is still 0, but now this is 0 also, and we've got negative 1 and negative 2. We're getting there. We still need some more zeros now. We now need zeros right here and right here. So to do that, I need to multiply. What am I going to multiply these by? Well, they all go into some version of 3. How about if I make row 3 into a negative 3 down here, and then I'll make this positive 3 and this positive 3. So row 1 by 3, row 2 by negative 1. And then row 3 now, I'm also going to have to multiply that out to get negative 3. So going ahead and doing that, I've got negative 24, 0, 3, and 150. Multiplying the second row by negative 1, that's 0, negative 8, positive 3, negative 58. Multiplying third row by 3, 0, 0. So it gets a little bit easier as we go with these zeros. And then negative 3, and then negative 6. Now I'm going to add, yep, you guessed it, row 3 to the other 2 rows, and I'll put the answer in the other 2 rows. So row 1, that's going to be still negative 24, 0, and now 0, which is what we wanted, and then 144. Row 2, I've got 0, -8, 0, and then -64. And at this point, I've got all the zeros. All I have to do now is divide each row by the number that's going to turn the remaining non-zero number into 1. First row, that's -24. Second row will divide by -8. Third row will divide by -3. So doing all that, I've got a 1, 0, 0, which is what we want, and then 144 divided by -24, that is going to be -6. Row 2 divided by -8, we've got 0, 1, 0, and +8. Row 3 divided by -3, 0, 0, 1, and 2. So then we've got x equals -6, y equals 8, z equals 2. Here's an example for you to try on your own. Give it a shot. All right, let's see what we came up with for our augmented matrix. So the first row, we should have 6, 5, 0 for the missing z, and then 16. Then 5, -3, -2, 9, then 5, 5, 1, and 10. So let's get zeros down here where the 5s are. 6 and 5s, those all go into 30. Let's make row 1 +30 and the bottom 2 rows -30. So row 1 multiply by 5, rows 2 and 3 by -6. Top row, I've got 30, 25, and 80. Next row, that's -30, 18, 12, and -54. And then we have -30, -30, -6, and -60. Let's add row 1 to rows 2 and 3 and put the answers in 2 and 3. And feel free to pause the video at any point. I'm just going through this assuming you've already got it on your paper, but if you need to change things, pause the video and change them. So adding rows 1 and 2 together, I'm going to have 0, 43, 12, and 26. Adding row 1 to row 3, we've got 0, -5, -6, and 20. All right, let's focus on getting the 25 and the -5 to be zeros now. Although, actually, that looks kind of nasty because that 43 is there. So I'm actually going to chicken out on those, and I'm going to focus on getting this 12 to be a 0. Let's go for the low-hanging fruit here. So to do that, I'm going to multiply row 3 by 2. So that's -10, -12, and 40. And then add row 3 to row 2. And row 1, we've already got a 0 there, so that's kind of nice. So doing that, I've got -30 or +33, 0, still a 0 over here, and then 26 and 40, that's 66. So at this point, there's really nothing else to do. I have to get 25 and -10 to be zeros. But it's kind of intimidating trying to think of a number that 25, 33, and 10 all go into it. It's going to probably be a big number. So this is one of those circumstances where it helps to take a step back so that you can take a step forward. What I mean by that is we're going to reduce each of the rows by as much as we can just to get smaller numbers to work with. So, I mean, row 2, obviously, it would be nice to reduce that by 33. That'll just give me a 1 and a 2. Row 1, all I can do is reduce that by 5. And for row 3, all I can do is reduce that by 2. But hey, every little bit's going to help. So doing that now, row 1 will be 6, 5, and 16. Row 3 again, we're going to have 0, 1, 0, and 2. And then row 3 will have 0, -5, -6, and 20. Ooh, that looks a lot easier to work with, making this 5 and -5 0 much easier than what we had before. All right, so here's what we're going to do. We're going to make this a +5. This is already -5 down here, so we just have to multiply row 1 by -1 to get a -5 up there. So doing that, we've got -6, -5, 0, and -16. And in row 2, 0, 5, 0, and 10. Let's add row 2 to rows 1 and 3 now. So row 1, that's going to be -6, 0, 0, and -6. Row 3, we're going to have 0, 0, -6, and 30. Time to divide. Row 1 by -6, row 2 by 5, row 3 by -6. So row 1, I've got a 1, zeros, and a 1. Row 2, we've got 0, 1, 0, and 2. And row 3, we've got 0, 0, 1, and negative 5. So we've got x equals 1, y equals 2, z equals negative 5. So in summary, this isn't always going to be the fastest way to solve a system, but as you can see, it's very organized. It's very clear to people who read this exactly what your steps are. And because we've got kind of a system to this, no pun intended, this is something you could write a computer program to do. So until next time, this is Mr. Sutton signing off.